Lakehouse, Warehouse, Eventhouse. A lot of houses in Fabric. If you want to know where your data belongs, after this video you will know it. When your data is coming in fast, when your data has a timestamp, and when you need rapid processing, then is Eventhouse the way to go. And today we will go into the details of Eventhouse. I will show you demonstrations, I will explain you the architecture, and I will go through the common questions from the community. So let's start with the center. When we have our Eventhouse, this is just a house, and I don't know whether you wondered from time to time about the house metaphor of Fabric. So I always thought, well, it's like we have the lake and we have the house, and is it like the boat house, but you don't drive with the boat, event boat, it doesn't fit. Someone told me then, well, just think about there's a lake and there's a house, and the house consumes water. And the water is coming from the lake, and the water is the data, and the data flows through the house and makes some useful stuff there, like for washing, for, I don't know, dishing, for something, right? And I found that quite helpful. So let's go to the event house. In the event house, you have multiple databases. These are called KQL database. KQL database. So let's say you have KQL database 1. This might be production. You might have KQL database 2. That might be analytics, for example. And you have the event house container. And the event house container holds both databases. This is like the group. Yeah. So this is the idea of an event house. And as always in Fabric, you have data in and you have data out. So regarding data in, you have our ingestion layer. This is the ingestion layer. And the ingestion layer, you have different toolsets. The first one is the real-time hub. The real-time hub gives you 100 plus connectors. It's like out of the box, it's pre-configured and really easy to handle. So for example, you might have a dedicated app that is available within this 100 plus connectors, or you might have a REST API. Then you can connect this through the real-time hub. Although these are our data sources. Next way to connect, let's draw a little bit nicer, is the event stream. The event stream can connect some typical event sources like Apache Kafka, or Azure Event Hub, or IoT devices. All these connect to the event stream. And you have a batch wizard, the so-called get data wizard. Batch. This is useful for files and storage, because there could be also files and storage that you want to proceed through the real-time event house. And of course, you can have different targets. So let's say the files are going to, so the get data wizard are going to our analytics database, and the event stream is going to our production database, and the real-time hub is also going to our production database, something like that. So this is like the basic architecture, and from there on, of course, doesn't stop here. You have the consumption layer, because that's always like the target. Consumption. You have different consumption layers. You will see that also in the demo. One very easy way are the real-time dashboards. This is easy reporting or easy dashboarding. It's heavily pre-configured. You cannot change everything, but you can change quite a lot. And it's live. That's the main advantage. Next one would be Power, of course, Power BI with direct query. Next way could be Data Activator. With automated actions. So you can trigger automated actions out of your data. So let's say all the data from production is going to either real-time dashboard or Power BI or Data Activator. But you have more options. You can pass your data to a notebook, Python or KQL. Or you can pass your data to a KQL Queryset. You will see that later in the demo. This is like ad hoc queries. And let's say our analytics data is going to notebooks and to the KQL dataset. In this way, you have like the complete picture for our walkthrough. And well, I like to draw that stuff because for me it's much easier to think when I see that something reveals one by one and it's not automated. But let's jump. I have recreated that, so it's looking really beautiful. So let's jump over to our shiny finished graphic. And boom, here we go. Isn't that looking really nice? So we have our data sources on the left side. There we go. These are the data sources. All the data sources flow to our ingestion layer. And from that ingestion layer to different KQL databases, in this case like production and analytics. All these KQL databases are tied to an Eventhouse container with a logical object. And they serve different consumption layers. So for example, the real-time dashboard or Power BI with direct query, or they can trigger the data activator in case of anomalies or in case the value reaches a defined goal or something like that. So you can trigger automated actions. They can go to a notebook with either Python or KQL, and you can even convert SQL to KQL. I will show you that in the demonstration. And we can move that to the KQL dataset, where we can do ad hoc queries. This is the complete picture how the data is flowing through the Eventhouse. Let's create an Eventhouse. It's very simple. New item, filter by keyword, Eventhouse. You need to provide a name as always and just hit create, and basically that's it. Once we are in, you see that there's a default database with the same name like the Eventhouse. And let's create a second database called Analytics Database. Simple as that. Now we have two databases in here. One, the default ones, which is empty, and the second one, the Analytics Database, which is also empty. Don't mess up the default database with the Eventhouse. They have the same name, but it's not the same. How is the internal structure of the Eventhouse, the so-called Kusto Engine? Let's have a look. We have the Kusto Engine over here. Oh, I'm still on the red side. Let's switch back to black. There you go, Kusto Engine. So this is our Kusto Engine. In the Kusto Engine in general, we have a workflow and a functionality called Queryset that makes parse, optimize, and distribute. It's like in every cluster environment, you need the distribution part, right? So parse, optimize, and distribute. The Queryset functionality. From that Queryset, the distribution is done to nodes. So we have obviously node 1, we have node 2, and in this way we have node n. These all are query executors. Query executor, query executor. And the Queryset distributes our queries to the different query executors. So this is like the core idea of the Kusto Engine. On top of that Kusto Engine, we have the client layer. The client layer means something like user queries, user Kusto queries, or a dashboard, or an activator. Data activator, right? So these are using the Kusto Engine. These are like consumers of the Kusto Engine. So how does it look inside? So we have this storage tiers. You will see that in the demonstration. So it's storage tiers. And the storage tier has basically two tiers. The first one is cache. Cache. It's called hot. It's a hot cache. Yeah, that's a local SSD. It's configurable. Yeah. So for example, you can say that's for 30 days there, or for 7 days, or something like that. That's a hot cache. And as like the other way, it's like cold storage. Cold storage is OneLake standard. It's still fast, isn't it? So, but it's a code because it's slower, right? And then you can define the retention. For example, it's 365 days or something like that. So that's like the cold storage. Yeah? And once the data is out of the hot time frame, it's automatically moved to the cold storage. Yeah? So these are the storage tiers in the that powering the Kusto Query Engine, which means that the different nodes use different storage depending on the policy. So let's say node 1 is using hot cache, Node 2 is using hot cache, and node n is using also hot cache, but there is some data that is not longer in hot cache. So this is a cache miss, which means cold read. So this is how it works. In the storage, we have the ingestion pipeline. And the ingestion pipeline has basically two different streams. The first one is the queued ingestion. Queued ingestion has 30 seconds to 5 minutes latency. It's high throughput, of course, but it's not real time. The second one is real time, which is streaming ingestion. This has less than 10 seconds latency. These are our two different ingestion pipelines, and both flow into the hot cache. So this is how the Kusto Engine and the storage layers works. So let's have a look at my nicely recreated diagram based on my drawing. So let's go through this again. So we have the core Kusto Engine with the query head and the different nodes. I put so n is here the first one, but still. The different nodes which makes the query execution. There's an auto scaling. The nodes use the different storage tiers, but the Kusto Engine itself is fed by or triggered by KQL queries from user, dashboard, or from data activator. We have two different storage tiers. The hot cache, which is a local SSD. You can configure the caching time, and everything that is outside the hot policy is automatically moved to the cold storage, where you define the retention time, which should be much longer. The cold storage is the OneLake standard storage, so it's not slow, right? It's just normal. It's not blazingly fast. If there's a cache miss, there's a read on the cold storage. And we have two different ingestion pipelines, one queued ingestion with something between 30 seconds and 5 minutes latency, high throughput, and we have the streaming ingestion with less than 10 seconds latency. This is counted as real time, and both go obviously in the hot cache. Second demonstration, it's more the theoretical side this time. So we have the system overview with some data. Of course, this is a newly created Eventhouse, so don't expect too much data in there, but you will get once you have data, and we will see that when we do the event streaming. Next, you see the activity and all that stuff, right? You can select the database and you can get data. You see you have a variety of options. So we have like a local file, we have OneLake, you have Eventstream, you have Azure Storage, Event Hubs, excuse me, I'm a little bit with Zoom it. Yeah, that's the wrong side. Yeah, but I think you get the idea. You have different sources, right? Local files like a special thing because it's file based. Eventstream and Azure Storage. Event Hubs is a very obvious one for IoT sources and so on. But also Amazon S3 pipeline data flow, and you can even connect more data sources out of that. For our case, we will go with the sample data. So it's pretty nice. We can simply import sample data in the database and then continue from that on. So we will do the weather analytics data. Let's have a look how the event stream flows to the event house. And in this case, because this is a little bit more complex, I decided to just go with the pre-created graphic. and not draw it by myself because I think it's easier to go through it. So we start with our IoT or device app. So something is creating JSONs, a temperature sensor or something like that. And this is then received by Azure Event Hub, which is a high-velocity smoothing engine for data. And this is tied to an event stream. So this transforms a bunch of events into a continuous stream. So irrelevant events are filtered, timestamps are normalized, and there's a schema alignment because schemas can change. It might be that you have different schemas per different sensor versions and so on, something that you cannot control. From there on, it flows into the Eventhouse database through streaming. We just talked about streaming, so we have this less than 10 seconds latency. It's automatically indexed. It's available in hot cache. We talked about hot cache, and it's created. So from there, once it is in the database, it's like stored, right? From there, to some degree, you can say, okay, now we are done. So fine, but we want to do something with the data. It's not just a self-containing ID to have data. So what we can do, for example, we can put it into the real-time dashboard, which means that we have some nice-looking graphs, right, or maps or whatever within the tiles, and there is a continuous loop of querying the data, which is called auto refresh. You don't have to do auto refresh, but you can, and this is one of the advantages of the real-time dashboard. So it's like auto refreshing and continuously updating your graphics. Continuously updating means continuously showing you the new incoming data, which is basically the idea. We can also execute data activator to trigger some events when conditions are met, like exceptions or like different levels or whatever. So that means data activator is also executing a query set rule, and the result is going back to data activator, and data activator is then checking whether the condition is not met or whether the condition is met. So this is basically how the data flow went from the device through the Azure Event Hub. So this is Azure, and from here on we are in the Fabric area to Eventstream, Eventhouse, real-time dashboard, and data activator. From there on, everything is Fabric. Where to store your data? So let's draw a decision chart. So store your data. So first, does the data have a timestamp? Like events do, like logs do, like telemetry does. So if yes, then the next question is, what's your latency requirements? Less than 5 seconds. Then you guess it, on the real-time way. So this is down here, real time. If you don't need less than 5 seconds, when minutes are acceptable, then you have more choices. So on the real-time monitoring way, you will end up in Eventhouse KQL Database. When minutes are acceptable, then you have the choice between the query language like KQL or ADX experience. Then you might want to go with the Eventhouse. When you have SQL or Spark, then you can do both Eventhouse for real time, because you can convert your SQL queries to KQL, and Lakehouse for historical data. We will see exactly that scenario in our demonstration. When you don't have timestamps, so then you are on the structural or dimensional side. Do you need ACID? Do you need updates? Then you need transactions. So you are on the, you guess it, warehouse track. When you don't need ACID, when you don't need updates, when you are just on the analytics path, right, then you are either on the Lakehouse part when you are going with Python or Spark. Yeah? When you don't have Python or Spark, so it means when you need SQL, then you will end up again in Warehouse. So first decision is, do you need real-time? Do you have timestamp data on it? If yes, this is your area. And then there's a decision mostly regarding latency. When you don't have real-time data, the question is, do you need updates? Then you're on the warehouse side. When you don't need updates, you could go with Lakehouse. We have talked about that pattern quite a lot. You might have asked yourself, why the hell is KQL so fast? Why are the queries so fast? So let's say you come in with a KQL query. For example, where the timestamp is less than 7 days. You guessed why I say that, because the next question, when you go into the query optimizer, is the metadata check. Is the time range coverage? So is our time range in hot cache? Yes or no? If yes, things are really great. We will have milliseconds of latency. Because this then went down to the hot cache SSD with the configured cache interval, let's say it's 30 days, right? It's compressed, plus indexed, plus local. Everything great from a performance point of view. When it's not in the hot cache, then we will have seconds of latency. Then we are on the cold storage, and it's compressed plus indexed, but it's in the ADLS v2 storage, which is OneLake, which means it's slow. The main difference is seconds versus milliseconds. And in the end, we deliver both back result to client. Do you have any questions about caching policies? Well, the community does too. Let's have a look at the community questions. Well, multiple users expresses confusion about a two-level hierarchy. Like a common pattern is, when I create an event house, it seems that it automatically creates a KQL database with the same name. So what exactly is the event house? It looks like the database is the event house. Coming from the Azure Data Explorer, I'm used to having a cluster and databases inside it. Is the event house the cluster? So, yes. Basically, the event house is the ADX cluster and equivalent. So it's managed, it's autoscaled. KQL database is the database inside. You can have multiple KQL databases in one event house. They share the compute, but they have different schemas, different permissions, and different data. The event house gives us the system overview and the unified billing, and the KQL database is where you actually put your tables and your data in. And Microsoft says the event house is a workspace of databases, which might not help because we have workspaces in Fabric too. Next one is hot cache storage bill. unexpected charges. So I set my KQL database caching policy to unlimited because I wanted the best query performance and I didn't think about it. My Azure bill for OneLake cache storage premium was 10 times that I have expected. 3 terabyte of hot cache storage at premium prices adds up fast. The default caching policy when enabling is unlimited, 3,650 days. A shotgun for users who enable caching without understanding the cost implications. So, well, one explanation or one answer. This is the most common Eventhouse mistake. You almost never want to have unlimited hot cache unless you have a very specific use case. Set it to the actual window your dashboards and your queries need, usually 7 to maybe 30 days. Everything outside that is still queryable from cold storage, it's just slower. And if your Eventhouse runs 24/7 with always on capacity planner mode, premium storage cache is included in your capacity charge. So for continuously running workloads, enabling always on can actually reduce your total bill. Next question is, we have Power BI, great for reporting. We have Eventhouse. How do they work together? I connected my Power BI to my KQL database. When I choose import mode, the data doesn't update unless I schedule a refresh. But I thought Eventhouse is real time. If I use direct query, the reports are slow. What's the right approach? Second user adds, hey, also can I use direct lake mode with Eventhouse like I can do with Lakehouse? So the answer is import mode copies data into Power BI's memory engine. That's why it doesn't update in real time. Direct query sends the query to the KQL database every time you interact with the report. For real-time operational reporting, direct query is the right choice. The queries are fast because they hit the hot cache. For executive dashboards that refresh every 15 minutes, scheduled refresh with import works just fine. Direct Lake is a Lakehouse Warehouse feature. It reads Delta files directly. Eventhouse uses a completely different storage format, Kusto extends, so Direct Lake doesn't apply. Direct Query is your real-time option for KQL databases. So we just heard about the uptime billing model, Eventhouse pricing. What's about that? So I recreated an Eventhouse for a POC, ingested some sample data, ran a few queries, and closed the browser. The next morning, I see Eventhouse uptime charges on my capacity metrics. I thought compute was only charged while running queries. Eventhouse charges via the uptime meter, a measure how long the Eventhouse is alive and consumes compute. The compute scales automatically, but while any data is in hot cache, the engine maintains compute resources to serve it quickly. So key behavior is Eventhouse auto-suspends after a period of complete idle. No queries, no active ingestion. Auto-suspend does happen immediately. There's a grace period. When suspended, it needs 5 to 10 seconds for a cold start or next access. And when running, the uptime CUs are consumed proportional to hot cache size and active load. So there's a pro tip. If you are just doing a POC and don't need it running, set the hot cache policy to 0 days, all cold, or better yet, delete the database when done. An empty Eventhouse with no hot data will suspend much faster and cost much less. Next community question. What's the difference between retention policy and caching policy? So I set the caching policy for 30 days, thinking that it means it will keep 30 days of my data. But data older than 30 days seems to have been deleted. Did I accidentally set the retention to 30 days? caching 30 days versus retention 30 days. So the root cause, when you set the retention policy to 30 days, instead of or in addition to the caching policy, that's what happened. So they are completely independent. Retention means how long is the data kept before permanent deletion. Caching means how long is the data kept in SSD, in hot storage. Completely different settings, but when you set the same value, of course the data is deleted after the caching time is done. So these are like the top queries from the community. Some common pitfalls. First one is treating Eventhouse as the database. So saying, okay, the Eventhouse is the database, is the confusion. So when do you need to create tables and so on? Always create a KQL database first and then create the tables inside of that. So the Eventhouse is not the database. Second pitfall is the default unlimited hot cache. Third pitfall is a mix-up between retention and caching. Retention means deletion, caching means hot, fast access. And the pitfall number 4 is Power BI import mode for real-time data, which kind of invalidates the idea of real-time data. Thanks for attending this time. This was about event houses. And hope to see you next time. When you want to get a notification when I release a new video, just hit subscribe on my YouTube channel. Thank you.